Hi everyone, I hope you are fine and welcome to Mastercam. So we are going to start the module number 7, which is all about the projects and applications. So in the previous videos and lectures, we have discussed all about the Mastercam. We start from the Mastercam overview, then we start and learn about how we can create 2D wireframe geometries in the Mastercam. As you know that we know that the Mastercam is a complete tool of CAD and CAM. So we can create 2D and 3D models in the Mastercam, and then we can make programs for that 2D and 3D models. So after learning of 2D geometries and 2D applications, we just learn how we can create 2D program for that 2D geometries or 2D wireframes. So we discuss all about the 2D face operation, pocket operation, contour operation, and drilling operation, all these things in the 2D operations. After completing the 2D operation, we discuss how we can create 3D models in the Mastercam. So we can create 3D models. We just discuss to use the block command, the loft command, the sweep command. We discuss how we can create 3D models using 2D wireframe geometries. We discussed the extrude command, we use the pattern command, we use the copy command in the Mastercam. So after creating a 3D geometry, we apply 3D toolpaths on the 3D geometries. So we use 3D toolpaths, we can easily say. So in the 3D toolpaths, we have two types. One for the roughing operation and one for the finishing operation. So for the 3D operations or 3D roughing operations, first we apply 3D roughing operations to the 3D models. This will be the parallel operations, this will be the radial operations, this will be the pocket operations, contouring operations, scallop, and project and profiles. So all these apply on the 3D models. Now, after completing the roughing operation, we just do the finishing operations on the Mastercam. So all these discussed in the Mastercam module. So after completing this module 3D, we step ahead towards the most complex geometries, which are being machined by the multi-axis. So we discuss about how we can create multi-axis toolpaths in the Mastercam. And we discuss about 3+1 and 3+2 Mastercam axis toolpaths, rotary axis toolpath, and 3+2 automated roughing, which is interesting to those who want to do in automatic multi-axis programming. So we discussed in 5th module all about the multi-axis toolpaths and its applications. In the 6th module, we discuss how we can create a simulation of all these things which we have learned in our previous videos. We create a tool, we create a tool path, we make a backplot, we create, verify, and we create simulation for our tool paths which we have done in the previous, like the 2D tool path and their simulation. We verify our tool whether it's going to be collide with the workpiece or any other things like the fixture. So this is all done in the 6th module, which is also known as the Mastercam Simulation and Code Expert. After performing the simulation, we just create a code which is going to be read by the CNC machine. So in the last module, we're going to create a project and we're going to make a part in the Mastercam. Then we're going to apply some strategies and then make it into real world. So before making into real world, we're going to make this program in a virtual machine, which I have here installed. So let's get started. Let me show you here. So I have already created a 3D model here. As you've seen that it's a model containing the hole features. Here some the pockets and some contour operations. So this is simple geometry which we are going to take into practice. So let me hide all these tool paths. So what you see over here is the pocket operation, and the pocket is being cut inside this block, and there is a hole inside this. And what you see over here is a holes of 20 millimeter in diameter, which are through all, and these holes are curve drive, which means that there is a curve here. On this curve, the holes are placed on that curve with the distance. So after getting these holes here, I just mirrored these holes to on this side. We have a very curved type profile here for different operation. So we're going to apply the roughing operation over here, and we're going to apply the finishing operation here. And then the last, we have the contour operation. Just make it easy to understand. I create a circular profile over here and some fillets around that block. So let's get to know about the operations which I have applied here, and then we're going to create a code for that. And after creating a code, we're going to apply this on a real machine or a virtual machine. Before getting into real machine, we're going to apply this code and application to virtual machine. So the first thing we have here is the facing operation. Let me untry all these operations to understand. So first thing we have the facing operation. We're going to remove some material from that. So for that piece, we have a 42 millimeter, or we can say a 42 by 50 millimeter face mill cutter to remove some material on the face. And we have some roughing operation for the pocket. So this is a square pocket. We're having the round edges. We're going to create a pocket over here. And the next thing we have here is the circular pocket here. We'll just apply a spiral type operation over here. Then the fourth operation is a rough flow line operation. Let me first show you the facing operation, just unhide this operation. So this is how it just looks like. Just giving a simple single cut over here to remove that material. And then the roughing pocket operation, we have this operation. So the strategy which I have applied is a spiral strategy. And the next operation is the pocket operation, which is created inside this hole or inside this circular pocket or circular hole, which is through all. Then the next operation, let me unhide this. So this looks like this. Here we have. So the next operation is the floor line operation, which is applied on this geometry. Let me show you. So this is the geometry, which is a spline cutted profile. And we just apply the roughing operation on this geometry. And after creating the roughing operation, we just apply the finishing operation here. So almost we have applied all the operations. Let me show you how it looks like. So this is how it looks like when apply finishing operation. Just follow the curves. So next operation is the pack drilling operation. It's a single type operation. We just don't need to apply the center drill because they have a large amount of diameter, which is 20 millimeter drilling we are doing. So for large sized holes, You don't need to create an center rate operation because it will automatically create a center for the hole. So this is all these operations is called the trailing operation, or you can say that hole operations. What you see over here is a curve, and these holes are curve-driven holes, same as on that side. The next operation which is being used is the contour operation, and the contour operation is applied on the outside of the geometry. So here it looks like this. Right. Now it's time to create post process, so we can simply say that we need to create a G code for our machine. So let's define that we have tool 1, 2, 3, 4. So we have total 4 tools. Face tool, then flat and mill 10 millimeter dia, then bar nose and mill, and then 20 millimeter drill. So let's start and make G codes for all these operations. So select all the tool group and click on the G1. We can say that go to machine and create on G1. This will create G codes or G and M codes for your machine. So make sure that you have an appropriate machine and appropriate setting to create G codes. Especially I have a Fano controller, so what I'm going to do is I'm going to make a G code for my controller, which is a Fano controller. Okay, so let's click on G1. We have selected all the operations, all the toolpaths. We don't need to create single operation. So we just select all these operations. We're going to make the program for all these operations. So just click on the generate. So the post-processing is mfn.pst file, and we're going to create an NC file for that. Okay, so I'm going to save this and name as a practice.cnc or practice.nc machine on the desktop. Or let me save this file to a folder named as practice. Okay. So what I'm going to do is I'm going to save this file in save as. Go to browse and practice. So this file will be used for your practice purpose. So you may get open this file and delete all these strategies and make new strategies for this model part. Okay, and after creating this, you have to apply this using the simulator. Okay, check all these operations on simulation. So as you see that we have opened the Mastercam Code Expert, the G codes have been created. Now it's time to see all the things here. So what you see over here, we have the T1 tool, face milling tool, and the T2 is flat and mill, and T3 is bar nose and mill, and T4 is solid carbide 20 millimeter drill. So we're going to save all these settings in machine, or we can say that we're going to set all these tool setups in machine. So let me delete some codes which do not need or do not required by the machine. So G21, I have removed that G code. So we have T1 M6. A code is not being used in the machine. We have applied the 3-axis milling strategies. And we have the H1. Okay. And next move towards the next operation, which is T2. Delete A0 because A-axis is not being used right now, so therefore we just move that is 0. So move that this code. The next tool. Now, same operation you have to apply on all these things. We don't need to add more things in this program because it's all this done by the Mastercam. Okay, so what you see over here is the G83 code. And okay. So we have done the editing. Let's check the last thing at the end, which is A0 right here. Okay. So save this file, and you can use this file on a real machine. So before applying to real machine, let's check this file on a virtual machine. So stay tuned for the next video. In the next video, I'm going to show you how we can check this G code on a virtual machine before loading these instructions into real machine. Stay tuned for next video. Thank you very much.